couple of things we need to discuss. All right. So remember, a rational, when you dealt with a rational expression, let's remind ourselves about a rational expression. So a rational expression looks like this. You would have something like 3x squared plus 7x minus 1 divided by x plus 6, let's say. Okay? That's a rational expression. You dealt with that last semester. There were quite a bit of things with rational expressions last semester. There's a whole chapter on it. So remember, though, a rational expression is where you had a polynomial divided by polynomial. That's what made it a rational expression. A polynomial divided by polynomial. That's what made this a rational expression. So remember, a polynomial is a combination of terms containing numbers and variables. So a polynomial is a combination of terms containing number and variables raised to a positive, or it could be 0, whole number exponents. So a polynomial is where you have one or more terms. It could be just one term, still considered polynomial. But those terms have to be made up of either numbers or variables, or a combination of numbers and variables. But your exponents, and that's important, your exponents have to be what kind of numbers? Positive or 0, whole numbers though, right? Okay, so here are some examples. 7x squared plus 8x cubed plus 6x minus 4. That's an example of a polynomial because it's made up of terms. All your exponents are positive whole numbers. 2, 3, 1. This is exponent 1. And you see that 0 that we were talking about, exponent 0? You might say, well, where's that 0? Well, here's something you got to remember. All right, listen carefully. So, do y'all remember that x to the 0 power is what? 1. Remember, any number raised to the 0 power is what? 1. Okay, you learned that in a previous course. So, if I have 8, if I have the number 8, do y'all agree that I can write 8 as 8 times x to the 0 power? Because what's x to the 0 power? 1, and 8 times 1 is still what? 8. So, listen carefully. This term, the exponent is 2. This term, the exponent is what? 3. This term, the exponent is what? No, 1, x to the first. This term, what's the exponent if I were to put a variable there? 0, because this would be minus 4x to the 0 power. Because x to the 0 is what? 1. 1 times negative 4 is still negative 4. So that's why they were talking about or 0. All right. This is not a polynomial. So this is not a polynomial. 3x to the 5th minus 7x squared plus 6x to the 3rd plus 8 to the 3/5. I'm sorry, 8x to the 3/5. I've got the 8x. 8x to the 3/5. So 3x to the 5th minus 7x squared plus 6x to the 3rd power plus 8 times x to the 3/5. What part of that made it not a polynomial? The fraction 3/5. Is 3/5 a whole number? No. So it's this right here that made it not a polynomial. Here's another one. So 3x to the fourth minus 7x cubed plus 3x to the negative second. What part of that made it not a polynomial? Negative 2. So remember, your exponents must be positive, whole numbers, or 0. Okay? Now, before we can continue talking about graphing rational functions, we need to talk about what we mean by the term degree. D-E-G-R-E-E. Okay, so let's talk about the degree of a polynomial. All right, so the degree of a polynomial. Okay, so if you're just looking at a term, so when we talk about the degree of a polynomial, you have to look at each term first. So let's talk about the degree of a term. The degree of a term. So to find the degree of a term, just one term, you're going to sum all of the powers. So the degree of a term is the sum of all of the powers. Okay? So, for example, let's look at this one. X to the fifth, y cubed. Degree is blank. What's the degree, do you think? 8. You add up the exponents. So 5 plus 3 is 8. Okay? Let's look at this one. 5x to the ninth. Degree is blank. 9. There's only one exponent, right? There's only one variable. That exponent is 9, so that's the degree. X, y squared, z. Degree is blank. What's the degree?
3.
No. 4. 1 plus 2 plus 1 is 4. You have to add up the exponents of all of the variables. What about this one? 5. Degree is blank. 0. See, only one person. Now you said none. I would not have taken none, because there is a degree. When you say none, it means there's no degree. There is a degree. It's 0. Now forget about our discussion. We just talked about that 5 is the same thing as saying 5x to what power? 0. What's that exponent? What's that exponent here? 0.
I'm sorry, 0.
0. Okay, 0. All right. So the degree of a constant. So all constants have degree what? 0. So if I had gone back and when we graph those polynomial, or when we graph those quadratic functions, let me find one that's in standard form real quick. All right. You remember this one? How many terms do you see? 3. What is the degree of that first term? The degree of that first term? 2. What is the degree of that second term? 1. What is the degree of that constant? 0. So when we talk about this quadratic function, sometimes it's referred to as a second degree function. Second degree function, quadratic function. It means the largest exponent is what? 2. When we talk about a quadratic function being second degree. Okay? All right, now listen carefully to this now. So you all know how to find the degree of a term. Okay. Now remember, the degree, we got to now talk about the degree of a polynomial. So a polynomial can have one or more terms, right? All right, so let's look at B part, a polynomial degree. Okay, now, okay, so I'm going to go ahead, before I finish this little part off right here, let me go ahead and actually look at an example to describe it. 3x to the fifth y cubed minus 4x y to the fourth plus 5x squared y minus 6. So we have this polynomial. So 3x to the fifth y cubed minus 4x y to the fourth plus 5x squared y minus 6. So we have this polynomial. How many terms are in this polynomial? How many terms? 4. There are 4 terms. 1, 2, 3, 4. Right? Okay. We all know how to find the degree of each one. So I'm doing this right here. What is the degree of this one? D means degree. 8. What is the degree of this one? 5. What is the degree of this one? 3. And what is the degree of this one? 0. Okay? Y'all got that part. The degree of a polynomial, though, the degree of the polynomial is the maximum, not the sum now, not the sum, the maximum term degree. Just write it as the maximum term degree. Now don't add up all of those numbers. That's not what a polynomial degree is. So don't say 8 plus 5 plus 3 plus 0. Is that clear? The polynomial degree is you look at each term, and the polynomial degree is going to be the one that has the largest degree. So what's the degree of this polynomial? 8. Okay. So the degree of this polynomial is 8. Okay? All right, let's look at one more. 4x squared y minus 7x to the 6th power plus 2/3 x to the 5th z to the 7th minus 3. So 4x squared y minus 7x to the 6th plus 2/3 x to the 5th z to the 7th minus 3. This polynomial has how many terms?
4.
4 again. What is the degree of this one?
3.
3. Well, let me ask you this. What do you think the answer is? What's the degree of this polynomial?
12.
12. Degree is 12. So this term is 3. What's the degree of this term? 6, right? What's the degree of this term? 7 plus 5 is 12. And what's the degree of this term? 0. So the degree of this polynomial is what? 12. Okay? All right. So we now know what degree is. We now know what the degree, how to find the degree of a polynomial. Okay? All right. So that part of the lesson was just talking about how to find the degree of a polynomial, because that's needed a little while.
Is this 3.1?
This is 3.5.